Okay, so here we're going to take a little break from focusing specifically on, the mechanisms of cell division and talk about why you should care. Okay, so one of the primary reasons why cell division is interesting for, a typical person is a failure of the cell cycle to behave normally um, leads to a constellation of a variety of different conditions that we all group together and call cancer. Okay. So essentially, what cancer is some kind of out of control cell division. Sorry, hold on. Hold up. Okay. So what do I mean by out of control? I mean cells are dividing perhaps too fast. Perhaps they continue to divide when they should stop. Perhaps they're dividing too rapidly. Perhaps they are dividing in a place where they shouldn't be doing that, right? So there's some kind of issue where cell division is happening when it should not. Okay. One interesting characteristic of cancer cells is that most cells, when they divide, when they hit each other, they stop, right? Because it's like, oh, we've repaired a damaged area or we've replaced damaged cells and we're done, right? Cancer cells don't do that though. They just keep dividing. And so you end up with, right? Like if you try to grow them in culture, you end up with this big pile. Okay. And so while the details of different types of cancer and how they affect the body and all of that vary quite a bit depending on what type of cancer it is, right? Fundamentally, what all different types of cancers have in common is that we're dealing with out of control cell division. Okay. One other kind of interesting thing about that is that cancer cells typically are abnormal, right? So you end up with an abundance of cells, but so in this image, right, they're showing them looking all like, weird. They're a different color and the nucleus is weird and the shape of the cells are weird, right? So not only are there too many of them, but cells are abnormal in cancer, right? Don't function normally. Plus, they look weird. Okay. And so, for certain types of cancers, literally the way that they do screening is they look at cells and they look, and they're looking for, do these cells look weird or do they look normal? Okay. Like they're literally visually looking at them. For other cancers, the way that they test is by looking for certain markers in your blood, right? Certain things in your blood that can indicate that you have some cancerous cells growing somewhere. Okay. So it kind of depends. All right. So that's what cancer is. Why are we talking about this now? And what does the cell cycle have to do with this? Well, it's out of control cell division. We already talked about that. But it would be useful also to talk a little bit about treatment. Okay. So, one of the things that is super frustrating for a lot of people about cancer is that even though, cancer has been plaguing humans for all of human history, right? We don't have a single cure at this point in time, right? Part of that is because each type of cancer is different, right? And part of that is because especially certain cancers, behave in ways that are really, really tricky and difficult to fight. Okay, so there's actually a difference between a what we call a benign tumor and a cancerous tumor. So benign is the term that we use to describe a tumor that grows in one place and stays there. So I'm going to say tumor that stays put. Now, some benign doesn't necessarily mean it's not a problem. right? Benign tumors can absolutely be a problem. Okay. So, for example, I'm thinking of various different types of brain tumors, right? Um, your skull is a limited amount of space. And if you have a tumor that's growing there, even if it's staying put, it, could eventually grow so large that it, damages various parts of your brain and causes all kinds of problems. Okay. So benign doesn't necessarily mean no big deal, it's okay, whatever. Okay. However, in some cases, that's exactly what it means, right? So some of you, I don't know if you guys will be able to see this on camera, but some of you, like myself, have the occasional mole in various places on your body. Okay. Some moles are cancerous and are very dangerous, right? And so we'll talk a little bit about that, not a ton, but if you have questions, you can certainly talk to me about it, or you can do a little bit of Googling. But many moles, healthy moles, right, are in fact a type of tumor, but they're a benign tumor, meaning they grow to a certain size and then they stop and they don't change, they don't do anything, they just stay put. Okay. A cancerous tumor does something called metastasis. Okay. So a cancerous tumor or a malignant tumor, malignant is the other, malignant means bad. Benign means like good or harmless, even though it's not always, but like the literal translation of the word benign. Malignant means evil. Okay. So malignant or cancerous tumors undergo metastasis. And so what metastasis is basically spreading. So if a benign tumor stays put, a cancerous tumor spreads. So in this particular example, we're looking at breast cancer, right? So they're showing you a tumor, right? And that tumor, if it is malignant, will get larger and larger, and eventually those cancerous cells will start to enter other parts, other tissues, right? So it invades neighboring tissues. So it's not just contained within that little tumor location anymore, but it starts to kind of spread out into different tissues. Ultimately, if it ends up in, so that the cancerous cells end up in blood vessels or lymph vessels, it can spread to other parts of the body. Okay. This is one of the reasons why, for most types of cancer, not all, but for most types of cancer, early detection is vital, because it is a lot easier to treat cancer, to get rid of tumors, if you catch them before they have metastasized. Okay. So it's just another little thing that describes metastasis, right? Here's an image that shows a fully metastasized situation, right? So they're showing you images of people um, with severe, right, cancer that's spread all throughout their body. Okay. Cancers, like I said, much easier to treat when you detect the tumor before it has a chance to spread. Okay. So let's talk about treatments for cancer for just a minute. Okay. So I'm gonna drop a little white screen in here. Okay. Now, let me say this. As far as cancer treatments go, there are, dude, ugh, sorry. Computer's just doing whatever it wants. It's not listening to me anymore. Treatments. Okay. There are a lot of new treatments. Okay. We're not going to get into them too much right now because you don't quite have enough background information about the immune system to understand them just yet. Okay. But we will talk about them perhaps if we have a little bit of time when we learn about the immune system at the end of the semester. Okay. So for now, we're just going to stick to like your, the OG, most commonly used treatments. Okay. First one, and often the best one, if it's possible, is surgery, right? So if you discover a tumor and it's fairly early and it has not yet metastasized, and it is in an organ where surgery is a possibility, that's often the first thing you do is cut that sucker out of there. Okay. Now, I'm writing. Sorry, stop talking because I'm writing. Okay. So let's go back to breast cancer for a second. Okay. So if you catch breast cancer early and all of the cancer cells are, contained within a tumor, sometimes, and the treatment varies, right? Depending on your circumstances. Okay. So I'm not, telling you what everybody does. Okay. Um, but often, what they'll do is they'll just surgically remove the lump, right? Remove a little bit of surrounding tissue, maybe check some local lymph nodes just to make sure that it hasn't metastasized, and that's the only treatment. That's all they need to do, right? Because they remove the whole thing. Boom. Okay. There are lots of other types of cancers where that's optional, where that's a good option as well, right? It becomes problematic though when you have cancer in parts of the body that can't be removed, right? Or where the damage would be too great. Okay. So, for example, let's say that somebody has pancreatic cancer and it's throughout their entire pancreas. Well, you can't live without a pancreas. So they can't just, surgically remove your entire pancreas. Okay. Because that's not going to work out. Or if somebody has a brain tumor, right? Depending on where it is, if it's like deep in the core of your brain, right? In the middle of your brain, the amount of, harm that would be caused by digging around, right? Cutting through your brain to get to the tumor, it might not be possible. And so I am acquaintances with a woman who has, she's had a brain tumor now for, how long have I known her? More, at least, I want to say at least 12 years I've known her. And she's had a brain tumor this entire time, and they can't do surgery because of where it's located, because it would cause, if they tried to surgically remove it, it would cause too much damage to her brain. So they use other treatments in that case. Okay. And she's been living with it. It's not great, right? But she's been living her day-to-day life with it because it's being treated differently. Okay. So that's one option. Sometimes it's the first step. Sometimes you can't do it at all. Sometimes it's the only step that's necessary, depending on what kind of cancer you're dealing with. Okay. Another one is radiation. Okay. So what happens with radiation? Radiation is really interesting. So radiation must be targeted. Okay. Meaning that essentially the way that radiation works is you're taking high energy radiation, right? Towards the high energy side of the electromagnetic spectrum. So when we were talking about photosynthesis, we talked about the electromagnetic spectrum, and you can't, if you're exposed to too many X-rays or gamma rays or ultraviolet rays on that spectrum, right? We talked about how that can be dangerous and it can cause mutations in DNA, or it can cause cancer, right? But the nice thing about using radiation, the sort of approach, the philosophy behind radiation is, what you're trying to do is you're trying to damage cells. But what you're only trying to do is damage the cancerous cells and leave the healthy cells alone. This is why targeting is so incredibly important, right? So my acquaintance that has the brain tumor, she gets radiation to shrink her brain tumor, and it has to be targeted at exactly the right spot, right? Because the goal there is to cause mutations, cause genetic damage to the cancer cells without harming your healthy cells. Now, sometimes that's really tricky, and sometimes some of the side effects are it damages some of the nearby healthy cells and you get burns or damage to those cells, right? So yeah, it has to be targeted because it's damaging to your cells, right? And it could cause healthy cells to develop cancer. but the goal is that you use it, you target it at cancer cells specifically to kill them, okay, so that they go away. All right. And the third one, and this is the one that most of you are you've probably heard this name before, chemotherapy. Chemotherapy is a treatment that involves drugs. Usually they're given intravenously. There's a couple of weird examples that are other forms, but typically you get an infusion, right? And the way that chemotherapy works is you're taking a drug, and that drug is actually really, really interesting. So there's a variety of different, there's a whole bunch of different types of chemotherapy drugs nowadays. But what all of them have in common is that they do something that disrupts the cell cycle. Right? And this is really, really interesting. Okay. So, why do we use this treatment? Well, remember that cancer is cell division that has gone out of control, right? It's too rapid, it's too numerous, it's too something. Okay. And so, by taking a drug that stops the cell cycle, right, it stops cancer cells from dividing, which is good. Chemotherapy is often used when cancer has metastasized or you assume that it has, right? Because it's a drug that you take intravenously, it spreads throughout the whole body. Yeah. So treats whole body. And so when somebody has had a situation where cancer has metastasized, right? Typically that involves some sort of chemotherapy at that point. Okay. What are the side effects of chemotherapy? So most of you, I'm sure, have someone in your life that you know that has had cancer. It's very common, right? There's so many different kinds. And many of us, it's, your risk of developing cancers in a general sense increases as you age, because the longer you're alive, the more you're exposed to things in the environment that can cause damage to your cells, right? So, not all cancers occur in older age, right? There are some, in fact, that are very specific to younger people, right? But many of us know someone, we have someone in our life that has experienced some form of cancer. Pardon me, I've got a dog being crazy. I'm just gonna pause for a second. Sorry, dog drama. Okay, and so some of you might be familiar with some of the symptoms. So some symptoms of chemotherapy treatment are your hair falling out. Okay, well, why does that happen? Well, the way that your hair grows is through cell division. And if cell division is stopped, then that means that there's essentially nothing holding the hair in anymore. And so it can fall out. Okay. Another common symptom of chemotherapy is you get nausea, vomiting, diarrhea, all kinds of digestive problems, because the lining of your stomach and your digestive tract is exposed to, it's a really difficult environment in there. There's acid, there's all kinds of stuff going on. And so you need to have healthy cells there all the time to protect you. And so if you're not able to do cell division, guess what? You can't make new cells that line your digestive tract, right? So you get really sick. Okay. People who are undergoing chemotherapy often are lethargic, they're exhausted, right? And part of that, they get anemia because they can't make new red blood cells. So they can't carry oxygen around their bodies very well. They also are immune compromised because they're not making new white blood cells, right, while they're on chemo. So the trick with chemotherapy is that the side effects are incredibly dangerous if you experience them for too long, right? So because of that, chemotherapy is not done continuously forever and ever and ever, right? Because you need to give your healthy cells a chance to recover from chemo. Okay, so treatment is dangerous, so not ongoing forever. Okay, I'm going to add a little note in all cells, right? So it stops the cell cycle in all cells, not just the cancer, right? So you might be wondering, well, how does that even work at all then? The goal of chemotherapy, when chemotherapy is successful, the goal is that you stop cell division in the cancerous cells long enough that they can't come back, right? That they die. But your healthy cells will come back. Okay. So chemotherapy is really, really difficult. It's a really, really difficult experience to undergo because the side effects of it are just so, terrible for a lot of people. Okay. Um, so those are the three sort of big treatments, right? And all of them do something to somehow address this idea of out of control cell division. Okay. Um, there are a variety of new treatments that are being implemented, right? Some of them are used right now, some of them are still kind of in the research stage. Um, the most promising, though, are treatments that involve finding ways to sort of train your immune system to do a better job of something that it already does, which is recognizing cancer cells as foreign. So if your immune system, which normally protects you from foreign cells, right? So when we were talking about blood types, last week, we were talking about this idea that, your body, your immune system recognizes cells that don't belong there, right? And it kills them. Okay. Well, your immune system does that with cancerous cells too. The problem becomes when your immune system can't fight strong enough or fast enough. And so, if we can figure out ways of sort of like fine tuning your immune system to be like, you go get those are the bad guys, go get them, right? And help the immune system function better, right? Then that would be a perfect solution because that way you don't have to deal with surgery, you don't have to deal with radiation, you don't have to deal with chemo, or you might have to do some of those, but you have this just another tool in the arsenal. Okay. So, so people talk about like finding a cure for cancer. The problem is because cancer is such a varied collection of conditions depending on which organs are affected, there is never going to be one cure, right? It's going to be a handful of different potential solutions. Okay. Sorry, kids, where was I think I had made my point. Okay. The last thing I want to say is I want to talk just real quick about how chemotherapy works, how it prevents cell division, right? So each drug is kind of different, but one of the sort of typical methods of, modes of action, what they call them, of chemotherapy is that it blocks the formation of a mitotic spindle, right? And that's what prevents the cells from dividing, right? So the cell is going through, right? It's going through the cycle, it's going through the cycle, it's going through the cycle, right? And then it hits prophase and it can't go past prophase because it can't, if a mitotic spindle can't form, guess what? You ain't going nowhere. Right. And so that's that. Okay. So I wanted to give you another little story about kind of why you should care, why the cell cycle is important, why you should care. Okay. So the last video is going to be about meiosis, and it's going to talk about how it's different from mitosis and why it's important. And then we're also going to talk about, what happens if things go crazy in meiosis. Okay. All right.